So 11:55. Hello, everybody. We hope you had an inspiring event so far, and we welcome you cordially to the breakout sessions. In this breakout sessions, the topic is enabling data sovereignty in the public cloud, a myth or reality. Your hosts for the next 30 minutes are Christian Banse. He is head of Department Service and Application Security at the Fraunhofer Institute for Applied and Integrated Security ISEC, and at the same time, head of the Office of the Fraunhofer Cluster of Excellence, Cognitive Internet Technologies, CCIT. Christian will give the technical lecture. My name is Tobias Steinhäuser from the Cluster Marketing of Fraunhofer CCIT. I will take over for the moderation. What can you expect? Anyone who wants to process data securely in the cloud will be able to use confidential computing in the future. The security concept creates protected hardware enclaves in the data centers to which even the cloud provider has no access. In the breakout session, Christian will talk about the advantages of confidential computing and how the approach can be implemented today. If you have any question, please ask them in writing in our chat. You can find the chat on the right side by clicking on the symbol of the two speech bubbles in the second row below. You can do this during Christian's lecture, or you can wait until the end of the lecture. We have scheduled a small Q&A session afterwards. In any case, please write down your question in English. We have participants from all over the world. Welcome. We have also prepared 3 small surveys that Christian will show during his presentation. We kindly ask you to participate. And now, Christian, the stage is yours.
Okay, thanks, Tobias. So, welcome again to the breakout session here, Data Sovereignty in the Public Cloud, Myth or Reality. So before we go into detail, I want to talk a little bit about what is actually data sovereignty, or how we see data sovereignty. And I think there are basically 2 main movements how to discuss the topic. And one is that comes, let's say, originally out of a more of a legal discussion, is that actually data sovereignty is the idea that data is subject to the laws of the nation or the country that is collected in. And you can still see that concept very much in government structures, for example, like the GDPR, where you see, okay, if you process some data, it should stay, for example, within the geographic region of the EU, or in some cases you can do that outside, but under certain rules and so on. But the general idea is, if you collect data in the European Union, you must uphold the laws of the European Union. And this is similar in other countries as well. And this concept then sort of was a little bit more, let's say, generalized or extended. And this was actually also, I think, part of the idea behind the industrial data space, for example, and originally dated out of the what is the German concept of Datensouveränität, which slightly translates in data sovereignty, but is slightly different in a way that what is meant here is actually the ability to retain control over how the data is used. So these are, let's say, 2 different views on the topic. One is more the legal point of view, in what kind of laws you must upheld if you collect the data. And the other concept is more, let's say, driven from a company or from a data itself, is then a way that if I produce some data, or if I collect some data from my customer, and this is my right to do so, I want to have the control over how I use this data. So if and this is, of course, inherently difficult, or actually both are inherently difficult, if you process data somewhere else. So not, for example, not in your own data center, not in your own domain. And especially then, this is, of course, comes to back to the topic we will discuss today, which is cloud computing. And for me, just to get some overview also of the participants here, we prepared a small survey question. The first one is that actually, which kind of cloud services do you use? So hopefully, it looks good. That is already coming to the poll. So I'll give you a couple of seconds, so maybe half a minute, to see what your poll's in. So hopefully this works now. There are some couple of votes. 5, yeah, maybe I've just come. So we just wait a couple of seconds here to have it. Oh, sorry. This is actually the wrong poll, I think. Okay, but doesn't matter. But we'll come back to this question actually later. So maybe I will present this first, and I will. Yeah. So I think this is the right one. So sorry about that. So we will come back to the other one later. So but first of all, so this was the idea to get an overview of which cloud services do you use. Yeah, this looks already good. There's a hard fight between the different service levels. There are multiple answers, a lot, of course. Yeah. Just give it a couple more seconds. So I think everyone voted. So hopefully this works if I present. Okay, yeah, thanks very much. So yeah, this is a familiar picture. In a way that is not really so it's interesting. So there are still a couple of people here that don't use cloud computing at all. That is also, of course, interesting, because we also want to understand a little bit more why that is, or what the current reservations maybe are. And then I think at the moment you can see that software as a service is really mostly used, but it's quite evenly. What is interesting for me is quite evenly distributed, almost between infrastructure and platform. So a lot of people are now using Kubernetes serverless functions, and this is something definitely that that was changed in the past. So let's go back to the presentation here. So of course, as you can see, cloud computing is a big market today, and depending on which analyst you talk to, it's about 250 billion or maybe even 300 billion market, and it's expected to rise. And as you could see here, not as clearly, but in a way that it's let's say still was dominant, that the majority share is actually software as a service. So a lot of people using CRM software, Office software, and so on. But it was quite evenly distributed in the poll here. And well, one of the perceived benefits, of course, is scalability, cost effectiveness. So these things come up if you talk about cloud computing, and of course also to some degree the outsourcing of competency. So if you're a smaller company, if you're not, let's say, or if you're coming from a domain that is not inherently too, let's say, digitalized, you might perceive some benefits in that somebody is taking care of backups, maybe even security, stuff like that. So there might be some benefits to it, and there of course are also some benefits to it. But the only thing that you need to keep a little bit in mind is let's say the issue of what is so-called the shared responsibility model, and this works in a way that the responsibility for some task, especially for example security, is actually split up between the provider and the user. So it's let's say naive to assume that just the cloud provider is responsible for all of the security, but you as a user also have some part in that. And this comes also back to something like confidential computing later on. So to sum up, basically you as a user are responsible for configuring certain things in the cloud, but the provider is responsible to provide those security measures. And still, and I think we'll come back to that for the poll in a second, is trust is still an issue. And I think maybe I've already saw a small preview of the poll that is now to follow. So there is still some uncertainty about, say, how much do I trust the cloud provider? I have usually a contract with them, so I'm fine in a way. But in a way, is you can take care of, for example, encrypting stuff on the way to the cloud. You can even encrypt it in the cloud. You can, or at least at rest, but still there is usually the question is of who actually holds this key. So is it just the key that basically the cloud provider generated for me? So there is still maybe, I don't know, or is it somewhere stored externally? Is it stored in an HSM? So on. So there is still some room to play. And the interesting thing is that there is still, at least before confidential computing came up in recent years, you still have the problem that the actual processing of data is usually unencrypted. So it's usually done in unencrypted memory at some form or another in the virtual machine, and comes back to basically legal contracts that the cloud provider says, okay, I'm not touching that, which is okay, which might be okay. And okay, and I can saw that the polls are already coming in. To show that here, and yeah, this is not too let's say surprising, is that it depends on the data. And what is interesting here is that there seems to be at least, and I think it's probably coming from those that use cloud computing, and we saw again that some people are not yet using cloud computing. So if they do, they usually also trust them. But there might still be reservations, of course, if you don't use cloud computing at all. And it comes back to it depends on the data. So you need some kind of decision. For example, is this really sensitive data? Is this now patient data? Is it data that is anyway public and we just store it on the cloud for availability reason? That it might be fine. And what can we do actually with that kind of data that is let's say super sensitive, and where maybe I see, okay, there is some perceived benefits in using cloud computing, but I do not want to use cloud computing for that particular data. Yeah, sorry, maybe just a little bit before we go into that is the perception is usually that Germany is still catching up a little bit on that, which is as we saw here, a lot of people are using it. But if you talk about the whole market in general, it's about 76% of all enterprises use cloud computing, according to this KPMG monitor. But if you dig down a little bit deeper, is that only 38% actually use public cloud services. So the rest is some kind of private cloud service, some managed stuff. So it's not really public cloud services in the way that it's an AWS or a Deutsche Telekom or whatever. And this is quite interesting. So there is some, let's say, perceived benefit in using those kind of technologies, but there seems to be still some reservations, and a lot of people actually report difficulties, for example, implementing security or compliance requirements. And this would be this is the last survey question we go from here, is that did you experience similar things? So what prevents you in a way to put data, for example, to external cloud providers? So especially if you have seen that you say, okay, it depends on the data, what kind of data you're putting in the cloud and which kind of data you're not putting in the cloud. Yeah, so far it's quite unanimous. Can already see some of the words. I changed a little bit. Yeah, I think so everyone, I think, participated. I think I can show this now. So yeah, so unsurprisingly, in a little bit, is that there is still this uncertainty about data protection and data sovereignty, and actually unsuitable services also quite interesting. So it seems that there was not the fit for the correct service. So this might also be something to work on. But it's usually the biggest reservations is basically security. And not because this is the topic today, is so what can we do here? So as I said before, there is still a little bit of gap when it comes actually to the secure processing of data. So you can secure it on the way to the cloud. You can even secure it quite good if it's resting in the cloud, I would say. But the problem is actually the processing. And this is now quite, let's say, the new hope here is that the new topic of credential computing could actually help here. And this basically is a new paradigm of technologies that is now a couple of years old and is now slowly moving also into, let's say, the mainstream processors and so on and so on. And there are a couple of different approaches to do that. And they are coming mainly from the hardware vendors of processors. So these are basically hardware-backed mechanisms. So they have usually either a special part of the CPU itself in modern CPU chips, or they have, for example, a dedicated secure processor that sits behind the CPU and deals with certain things. And the general idea is that you encrypt it. So right, it comes back to encryption. And there are the two main, let's say, approaches is you can either encrypt the whole virtual machine memory And you can already see here that this is mainly targeting in a whole virtualization scene, and of course then also cloud providers. So you can use services, for example, there is AMD SEV, which basically encrypts all of the memory of a virtual machine, which of course has certain advantages because you can just transparently use your existing VM. Might also have some drawbacks because you have quite a lot of, let's say, big target that you need to secure and so on. And there are also other technologies. So basically, let's say a smaller target, which is from a security point of view usually good. If you have something smaller that you can verify, it's a little bit easier. Of course, this is not as transparent as a VM in a way that you might need to adjust your programs a little bit to actually to have it work with those kind of technologies, right? So this is the obvious drawback here. But in general, how does it work? So basically, in cloud computing, it works like this: that you have basically VM hosts running in the cloud that host your virtual machines or a virtual machine of the customers, and those now have, through the secure processor, basically the ability to create a secure processing environment within that VM host. So in case, as we said from SEV, it's basically a regular VM, but the VM memory is encrypted. And it's encrypted in that way that the encryption key never leaves the hardware. So basically, this encryption key is only been negotiated between the secure processor and the main processor, which then uses some extra features, for example, to accelerate virtualization. So basically, the cloud provider doesn't have the key. Actually, also sometimes you don't have the key, but you don't need it because it's basically just needed between the CPU and the secure processors to encrypt and decrypt memory during runtime. And then basically you can use that as a regular VM, for example, in the case of AMD SEV. And the good thing is that you can verify that status remotely. So you can basically ask the VM, so how are you doing? Are you still encrypted? And the cloud provider cannot manipulate or cannot intercept that, because basically the root of trust in this remote attestation is not the cloud provider, but it's the hardware itself. So basically, you get a sort of a challenge response mechanism here. You can ask the VM that with a fresh challenge. It will respond with a signed answer, and this answer is then actually, for example, signed by AMD or Intel inherently in the hardware, and then you can later on check that if this is really now an AMD or Intel chip that you just talked to, and then from there on it's just basically like regular infrastructure, so service computing, in a way that you then connect to the VM. You still need to make sure, of course, that it's really your VM, so you need to make sure that this is the correct identity if you're using SSH, TLS, and so on. So this is still, once again, your responsibility. So even with confidential computing, shared responsibility does not go away. So you always have that. But it makes things a lot easier in a way that you can now process certain sensitive data securely without, let's say, this worry in the back of your head that your cloud provider might intercept certain data, for example, right? And so can I use that today? And the answer is yes. So if you look at what I call here the usual suspects, so basically the big three cloud providers is that you can use VMs within /GAIA-X, for example, or Microsoft Azure. You can use encrypted VMs with AMD SEV on Google Cloud Platform, and you can use what is called Nitro enclaves on AWS, which work similarly. I think I'm not too completely familiar how they work technically. That's quite new. There was a recent white paper from AWS. So far, I've not seen that they work based on either SGX or SEV. But this is something that we might need to dig a little bit in deeper. I think I also see some people from AWS here, so maybe they can comment on that later if they know. And what is a bit interesting is, where are the offerings of the German cloud providers? So and I think somebody else was also asking already the question: are we talking about GAIA-X here? Yeah, to some degree. So my main challenge here was actually, so can we do that with the big cloud providers today? And there are, of course, discussions in GAIA-X that this kind of things are necessary. So we need those offerings. We need those offerings also from Deutsche Telekom and whatever. So definitely this is something that needs to be considered, but as to my knowledge is not yet there. So this is still a little bit of room to play with, I would say. And I think this is quite this is good market for cloud providers to really offer services in that way. And so how does this actually also fit together with things that that you've heard throughout the day, for example, with EDS technologies? So basically, what you can do is you can now bring back together, or let's say together, the world of the industrial data space and focused on let's say scenarios where you run either your own data center or your own edge devices, or you have some, let's say, more control over the physical infrastructure in the IDS world. And now this is actually a very good bridge for those requirements that need to handle sensitive data to, for example, put your IDS connector into such a secure enclave. And this might work quite simple, for example, in the way of SEV, with some let's say tie-in code. It might need some adaptation if you're using other technologies, but this is basically something that we are dealing now. So if you're interested in doing that, please talk to us, and we can see how we can help you there, how we can set up projects to do that, because this is basically the way, at least for us in Fraunhofer AISEC, moving forward to also enable, and I'm not sure if you heard the talk about the different certification schemes in the IDS, so there are like this basic and Trusted Plus, and we are working towards enabling such things also, for example, the trusted profile to do that in cloud computing. So I think we're not quite there 100% yet, but we are on the way to do that, to even achieve such scenarios, for example, then on public cloud computing, which I think would be very interesting, because you have sort of then the best of both world approaches in a way, and you can do things like strong enforcement of usage policies, the integrity of your data, secure sharing of data, and so on. And you can basically imagine, if you talk about such a whole data sovereignty stack, what you can do on a different level. So as I said before, so in transit at rest, it's basically done. So I think this is the cloud providers are actually already using quite good mechanisms here. You just need to use them. There's still some, let's say, wiggle room in how to configure them, and there was a lot of times things did, for example, access control was not configured, let's say, good per default, not without going into much detail, but you obviously see many things that, oh, data was leaked from the cloud and so on. This was basically access control. Somebody forgot to set this particular switch that some things need to be kept private, and to some degree it was not set private by default, and things have changed so that the defaults are already a lot better now. But it's up to you to configure that. Similar with storage encryption, there's still an inherent issue: who has the key, who has generated that key, and so on. But there are also solutions for that. And now you can also do that same, for example, during computation. So you can use those kind of technologies to not just secure the data in transit at rest, but also during the computation. And if you do that, for example, with an IDS connector, you can also do that when sharing the data with others. And if they also using those kind of connectors also in those secure environments, or adhering to certain trust profiles, you can then have a complete chain basically that also enforces this usage control over your data. And I think that's quite a good, let's say, perspective for the future. And as I said before, so if you're interested in that kind of concepts with a more, say, also deep dive technical, and then we can do it here, definitely just talk to us. And I think I'm not quite sure how many minutes we have now for discussions, because the agenda was a little bit out of sync, but we definitely have some time for discussion. And I would ask Tobias, maybe just, I think there were some couple of questions already during the presentation, so maybe you can, we can have a selection of discussed topics moving forward here.
So yeah, thank you, Christian, for your talk. And yeah, we have some minutes left, 5 minutes. Here's a message that at 12:24 we will end this breakup session. So yeah, if you have questions for Christian concerning confidential computing, yeah, its relation with the GAIA-X or IDS-Zertifizierung, then yeah, use the chat function. Please use the chat function here and write down your questions. But yeah, maybe if there's no question, maybe I will ask Christian, because the first question was here. It's about, is the session about GAIA-X? Maybe you can again explain the link between the concept of international computing and GAIA-X and secure data rooms and data spaces.
Yeah, sure. So, well, basically, as I said, so it's not inherently about GAIA-X yet, because, well, things are also still, let's say, in a definition phase in GAIA-X. And there is a strong discussion going on, also if you follow the discussions on GitLab and so on in the GAIA-X community, that we need to, let's say, leverage those kind of technologies also in GAIA-X, or let's put it the other way around. These kind of technologies are there, so not available, and it's basically a little bit up to the cloud providers to actually now offer these services. And I think what I can, let's say those German cloud providers, and then in the end, GAIA-X will be, or let's say the general idea of GAIA-X is to have this mesh or this virtual hyperscaler, so not build yet another AWS or Microsoft Azure, but basically leverage the existing infrastructures also with those players. So this is definitely not something that you say we want to keep them out. So build something based on an existing ecosystem. And of course, then I think the message is, again, to the cloud providers that there is the inherent, let's say, potential to use that there, and I think the market is already there, and this also has been proven by the move of the big cloud providers that they are now offering those services since, let's say, half a year or almost a year, and yeah, so I think which degree it's mandatory, it's another discussion. But as I said, I think it's up to the cloud providers in the end to build up services that go into in this direction.
Okay, thank you, Christian. Maybe now we have some questions from the participants. Let them have time to paste something in the chat.
Yeah, otherwise we will close a little bit earlier for lunch.
Okay. Just one more question, maybe, because I don't know if all the participants know about the Fraunhofer CCIT. Maybe you can just say some words about this cluster of Fraunhofer and also the connection to secure data rooms and what offers you have for industry or partners.
Yeah, so basically the idea is that we, within the cluster CCIT, we combine the competencies of different Fraunhofer institutes, so that you sort of have one contact person for the industry, and the whole, let's say we also bundled all the activities around the international data spaces within Fraunhofer, also within the CCIT cluster. And basically, we offer a variety of services from consulting to trainings to workshops that if people are interested in those kind of technologies and want to see, can I use them already? How much effort would it take? Does it fit my existing ecosystem of services and so on? And this is definitely something that feel free to talk to us about it, and can see how we can start a collaboration here. And we are also always eager to, let's say, to build things. So not just talk about it on a conceptual level, but also say, can we prototype some existing services, some cool things, also with those kind of technologies that we talked here today.
Okay, thank you, Christian. Yeah, it's just for me to let you know that we have an explanation video about Fraunhofer CCT and cognitive internet technology. So I will post it here, the YouTube link. In just 2 minutes, you will know what the Fraunhofer CCIT is. And yeah, if there are no more questions, as Christian said, okay, as I'm seeing here 24, so we have to end. Thank you for your participation. Thank you, Christian, for the talk. And yeah, let's go on to the event and have another inspiring session here. It will continue with a farewell message and a second breakout session. So
okay, then
yeah,
bye.
Have an inspiring event. Bye.